Now it's time to discuss a core building block for every C# app, classes. In this module, you'll see how classes can operate like book headings. We'll look at 5 different reasons to create a class, and we'll explore concrete ways to measure class code quality, such as cohesion, naming, and size. We'll look at common anti-patterns like primitive obsession, the proximity principle for organizing code, and the outline rule for structuring your logic. Let's get started. Throughout the course, we've used the metaphor of thinking like an author to help us write clean code. Classes are the heading in this metaphor. A heading in a book provides a high-level summary of the content inside. When a reader searches for a specific concept later, these headings provide a roadmap. Headings make a book more scannable and help the reader comprehend the paragraphs inside more easily by providing a high-level summary of the topic being discussed. A well-written heading should contain a number of related paragraphs underneath that stick closely to the topic outlined in the heading. In the same way, well-named and targeted classes provide a strong cue to the high-level intent of what's inside, and thereby aid the reader. Just like a heading with related paragraphs, a class should contain multiple methods that relate closely to a single clear responsibility. There's a number of logical reasons to create a class, or extract a class from an existing class. The first and most obvious reason is to model an object. These objects can model either concrete or abstract concepts. Classes are especially helpful with abstract concepts because they assign concrete names and behaviors to these concepts and thereby make them more approachable. This aids the reader and helps us stay organized. If the methods in your class have little to do with one another, it's a sign the class has low cohesion. Classes with low cohesion should be split up into separate classes with more targeted responsibilities. To promote reuse. Even if a piece of code could be part of a larger class, put it in its own class if it is useful for another program and thereby easier to work with. It's also useful to create a class to reduce complexity. Creating a new class means that the reader doesn't have to consider the mental weight of a solved problem. The class hides away the complexity and groups related operations behind the scenes, out of sight, out of mind, and allows somebody to just trust that that piece will work. Finally, they can be useful to clarify parameters. Classes can greatly simplify information passing when complex data structures are involved. Classes can convert a loose bag of related variables into something more concrete, easier to reason about, and more tangible. If you end up passing the same variables to several functions, then quite likely those variables and functions should be a class. Let's explore a few of these items in more detail. This is the old Detroit Theater in Detroit, Michigan. It's now being used as a parking lot. This is highly inefficient and odd, but that's not a surprise because this wasn't ever intended to be the responsibility of a theater. We often run into the same problems in our classes when we assign responsibilities to the wrong class or expect a single class to do too much. In his book, Structured Analysis and System Specification, Tom DeMarco described the concept of cohesion. Cohesion is a measure of how strongly the responsibilities of a class are related. Highly cohesive classes have closely related functionality. This makes them easier to read. Since a class name serves much the same purpose as a heading in a book, it's easier to understand what a class is doing when the heading truly summarizes its focus clearly at a high level. Highly cohesive classes are more likely to be reused because the logic inside is more likely to be discovered in the first place. When classes contain large groups of unrelated methods, it's far less likely for other developers to even find the code. They're thus more likely to reinvent the wheel and break the dry principle by repeating the same logic in their own way in some new class. Recall that the discussion we had earlier in the naming module was about magnet classes. Classes with low cohesion often have poor names as well, since it's difficult to name a class with many disparate responsibilities. These classes are often given overly generic names that attract lazy developers who don't want to think about where their logic truly belongs. To avoid attracting lazy developers, it's important to keep class names descriptive. This helps keep cohesion high. Now, this principle is closely related to Bob Martin's single responsibility principle, which states that each module should do one thing and one thing well, and it should have only one reason to change. To avoid creating low cohesion classes, keep an eye out for a few things here. First, watch for methods that don't interact with the rest of the class. In highly cohesive classes, the methods and properties work together to accomplish the task. This regular interaction is a sign the class is cohesive. Low cohesion classes feel more like a random set of functionality, which makes them hard to understand and maintain and less likely to be reused by others. In a similar way, watch out for fields that are only used by one method. Fields should be used by many methods in the class, and if they're not, consider if the field or set of fields is a sign that the related functionality should be extracted to a separate class. Source control can also help tell the tale of classes that are doing too much. If you see a class that receives many more commits than average, it's likely a candidate for refactoring to separate classes with higher cohesion. Let's consider an example of a class with low cohesion. This vehicle class allows you to edit vehicle options, update pricing, schedule maintenance, send maintenance reminders, select financing, and calculate monthly payments. Now, these items are all generally related to vehicles. A class handling these rather disparate responsibilities, though, is likely to have low cohesion, because the methods that deal with maintenance will utilize a very different set of fields than the vehicle options, and financing and payments will require complex math and business logic that is totally unrelated to the simple tasks of editing vehicle options. So let's look at a potential refactoring. So this refactoring of the vehicle class breaks it into three separate classes. These classes are more cohesive since they perform a closely related set of functions. The vehicle class now handles the responsibilities that are very specific to the core vehicle data, like editing vehicle options and pricing. The vehicle maintenance class handles scheduling maintenance for vehicles and sends maintenance-related reminders. The vehicle finance class handles presenting financing options and calculating monthly payments based on the selected financing options. Imagine I need to add a new feature for financing a vehicle. By placing the financing logic in a separate class, I now have an obvious and more approachable class to review and modify. I've also reduced the risk because my change to the vehicle finance class should be highly unlikely to impact any functionality in the vehicle maintenance or vehicle classes. Also, keep in mind that the cohesion becomes increasingly important as a class grows larger and logic within the application becomes more complex. In a very small, simple system, mixing these concerns together in a single class wouldn't necessarily feel burdensome. But imagine if each of these highly cohesive classes on the right contained 1,000 lines of code. Then the idea of being placed together would sound extremely painful. You likely recognize the examples in this slide from the naming module. But with classes, names are so critical for assuring high cohesion that this merits discussing again. Classes with overly general and undescriptive names lead to magnet classes, and as we know, magnets attract items. In the same way, classes with poor names, like these, attract lazy developers. Classes with names like common and utility often grow quickly to thousands of lines of unrelated code. When you instantiate a class, you should have a clear idea what it is and what it does just from the name. This is why classes should typically have noun names. The more concise the name, the smaller the class. So start with naming well and strive for class cohesion. You can roughly measure class cohesion by reviewing how many methods use the class's instance variables. Instance variables used by only one or two methods are an indication that those methods could be refactored out to another class. Developers often complain about code, but how many times can you recall complaining that a class you were reading was too small? Yeah, it's certainly possible to make this mistake, sure, but it's a real rarity. Developers nearly always err on the side of creating classes with too many disparate pieces of functionality. That said, here's a few signs that a class is too small. If two classes rely heavily on one another and call a large portion of each other's methods, then they might be a candidate for joining into a single class. If you see one class that relies heavily on another class, then this feature envy might be a sign that the two classes belong together. Finally, overly small classes can make it difficult to understand how the system hangs together. There's just too many small moving parts. This can lead to other issues like classes that are tightly bound to one another. But be forewarned, these issues are all nearly unicorns in the real world. Developers rarely make this mistake of overly small classes and very often make the mistake of creating monolithic classes with way too many responsibilities. Object-oriented programmers can easily slip into passing around loose pieces of related data that should really be encapsulated within a class. This dirty example breaks the rule of 7 by having more than 7 parameters. These parameters are all clearly properties of a user, so a user object should be passed into this method instead. Now, there's a trade-off to be made here. If the method used only 1 or 2 parameters from a user, then passing the specific necessary properties can help clarify the precise data dependencies and the method's intent by showcasing what is required without viewing the method body. The clean version lumps related data items into a class. There are multiple benefits to this approach. It helps the reader conceptualize the code and intent by assigning a well-understood name to the group of parameters. It takes something implicit, in this case a long list of parameters, and makes it explicit by assigning the group a name that can be reasoned about. Properties can encapsulate business logic and rules for their values to avoid putting in ad hoc code wherever these primitives are utilized. If another property is later added to the user object that needs to be leveraged by this method, the method signature itself isn't impacted. And finally, you can easily find all references to the user object in code. When you pass around a loose set of primitives, finding all the references to those primitives in the related user data can become a daunting task. So remember, if you're passing around a set of related data items, it's a sign that it's time to create a class. Readers naturally read from the top down. Thus, it's really helpful to keep related actions together. It's very natural to be reading a method and see it call another method. So if the callee is the next method below, the reader's job is very easy. It's harder to read and work with a class when you have to scroll up and down or use a keyboard shortcut to jump back and forth while reading function calls. This class snippet is laid out top down. Notice how when you read the call to validate data, you can glance down and see that it's the next method in the class. The next call within validate registration is speaker meets our requirements. You'll notice again that it's placed right below validate data, so it's still conveniently close. Now, this is of course a loose rule, since methods are often called multiple times from different places, and you can only place a function in one spot. But, when possible, it's helpful to the reader to keep methods that interact or that are closely related to one another close to each other in the class. A well-written outline has multiple layers. It defines high-level concepts and drills down to specific points made under each concept. Or think about a well-written book. If you're thumbing through an unfamiliar chapter looking for a specific high-level idea, it's helpful to have section headings. Then you can easily scan for a particular high-level concept. Classes that utilize the outline rule offer the reader the same benefit. See, the outline rule increases the signal to noise of our code by providing the reader with multiple layers of abstraction. These layers are provided by creating well-named methods that describe the high-level steps involved in a process. Each of these high-level methods delegate to lower-level methods that ultimately do the work. With this style, you may have some methods that are literally nothing but a list of related method calls, and that is okay. It converts something implicit and potentially confusing into a well-named structure that's easier to understand and better conveys intent. By doing so, you build an outline into your code, allowing the readers to reason about your code at the layer of abstraction that's most helpful to their purpose. Often, classes contain one or two high-level methods that drill down into child methods. With a structure like this, a high-level overview of the algorithm involved isn't clearly provided. Consider this cleaner example instead. You can see a high-level overview of the three methods involved. If you want an overview of what method 1 is doing, you can review the names of its three child methods. If the functionality outlined in method 1a is of interest, you can even see that at a high level it involves the steps outlined in 1a1 and 1a2. When a class is designed to honor the outline rule, it's easy to review its functionality in the layer of abstraction that is most useful to your purposes and dig down to the right level of detail as needed. Now, this is a tricky concept to get right at first. In the next module, our demo will walk through implementing the outline rule in an example application. In this module, we explored clean practices for creating C# classes. We focused on cohesion. Ideally, each class should be composed of strongly related methods. Specific class names help encourage cohesion. Avoid creating classes with generic names since they can become a magnet for unrelated logic. Classes are rarely too small, but a few signs are inappropriate intimacy, which is when a class is tightly coupled to another, and feature envy, which is when a class wishes it had all the features of another class. Watch for primitive obsession, which is passing a variety of related values around instead of encapsulating them in a class. Remember the proximity principle. Try to keep related code close together. When related code is composed together, jumping between files is minimized. Try to organize the code so that it can be read in a top-down manner. Finally, remember the outline rule, which says that it's helpful to write our code at multiple layers of abstraction. When the code is collapsed, it should ideally read like an outline. Doing so allows readers to jump around the class quickly. They can speed read through the code at their desired level of abstraction. In the next module, we'll consider code comments. We'll look at bad comments to avoid and good comments worth considering.